Okay, if x is greater than 0 and y is greater than 0, which of the following expressions is equivalent to
that giant mess? Yeah.
Square root of x minus the square root of y.
Okay, good. Okay, you know what strategy we're going to have to use here, right?
Mm-hmm.
What are we going to have to do?
Variables, I guess.
Plug in values for the variables. Now notice they don't give us potential values for x and y. They tell us x has got to be greater than 0 and y has got to be greater than 0. But they don't say like, okay.
4.
Yeah, absolutely. That's absolutely perfect. Does that make sense?
4? Yeah.
Yeah. X is 9 and y equals 4. Now again, this is sort of where there's an art to plugging in values in places of variables. You can't just kind of pick anything. And we know x has got to be greater than 0 and y has got to be greater than 0. So we got to work within the requirements of the limits of the question. But you got to be kind of smart about it, right? You don't want to plug in like a 10 for x and a 5 for y. If you do, I don't know what the square root of 10 is. I don't know what the square root of 5 is. It's super. I mean, it's a decimal that goes on forever. I don't even want to deal with that. So you got to be smart about it, okay? But I think this is going to work out perfectly, okay? So let's plug in and a 9 for x and a 4 for y into this expression, and we'll find out what that equals. Does that make sense? You're good, Jax. As long as it's legible.
Yeah.
You're good.
See?
You're good.
All right.
Okay. All right. So, so we've got 9 minus 4 in the numerator. What's 9? Well, yeah. What's 9 minus 4?
9 minus 4 is going to be 3.
Let's double check that.
Oh, no, that's not going to be 3. It's going to be 5.
It's going to be 5. You're good. To add and subtract, I highly recommend it. Really. That's just 3. And
so
2.
just 3 minus 2.
Yeah.
So it's going to be 1.
Yeah, in the denominator, right?
Yeah.
And the 5, what's 5 divided by 1?
5 divided by 1 is 5.
Just 5. Okay. So when x is 9 and y is 4, this expression in the question gives us 5. This expression right here gives us 5. Does that make sense?
Yes.
And we're trying to find the expression that's equivalent. What does equivalent mean?
Equal to.
Equal to. So all we've got to do is plug in that 9 for x and 4 for y into the answer choices, and the correct answer choice has to give us what?
5.
5. Does that make sense, Jackson?
Yes.
Beautiful. I think we've seen a number of questions like this before. None quite as scary looking as
4.
Okay. Now again, let's stop here and don't worry about the calculation. Let's just use some basic logic. Is that going to give you 5?
No, it's not going to give you
There's
5.
no way, right? Because
No.
the square root of 9, the square root of 9
is.
Well, we know.
So 9 plus 4. 9 plus 4. It's going to be 12.
Even if we were multiplying by 1, even if those were 1s, like that would give you 13, something bigger than 5. And those are bigger than 1. It's 3 and 2 plus 4 times 2. And again, that's just not. It's going to give you 27 plus 8. It's just 35. It's not 5. So D is gone. This answer choice C. Any questions about that?
Nope.
Same strategy. Plug in the values in place of the variables. That's all this is. If x equals 5, we can pick something a little bit smaller. It's going to make it a little bit easier.
So 4.
We could do 4. I'm going to make it even simpler, man. We could plug in a 1. That might work. I'm going to make x equals 2.
16.
16's not 8, man.
Nope. So D is the answer.
Answer choice D. And that's it. And you could plug in a 1 for x, plug in a 3 for x, you get the same thing. There's going to be 8 rows.
And then we kind of saw that because of the diagram we did.
Yeah. There's going to be 8 rows. Question number 3 for me, please. This is right off a TSI practice test.
Okay. In the XY plane above, point C has coordinates.
For this line. Okay. Now, I've got a section on the rules for mathing where I talk about graphing, and I think I've got some stuff here like on, y equals mx plus b form, where m is the slope, which is the rise of a run, b is the y-intercept, and all that. And that's useful here. If you're really comfortable with that, you can think in those terms, and that's fine. There's another really easy way to solve this problem, which is that if we know a line, if we've got a line, and we know some of the points on the line, even one of the points on the line, and we know 2 of the points on the line. One of the points on the line is 6, 9, right? And let me make it real clear. That 6, that's an x value. and that 9 is the y value, right? Which makes sense at this point right here, this point C. That is the point 6 it comes from, 6 comma 9.
Yeah.
Okay.
Yeah.
Okay. So, and that's just, it's called an ordered pair. The first number in an ordered pair is the x value. The second number is the y value. So 6 comma 9, when x is 6, y is 9. It's got to be. Does that make sense?
Yes.
Okay, great. Another point we know 0 comma 0, right? That's the origin. Okay, that's where the x value is 0 and the y value is also 0. Does that make sense?
Yes.
Okay, great. All right, so what we can do here is plug in either of these points into the answer choices, and the correct answer choice has to give us a true statement for both those points.
Two times 6 is 12
Uh-huh.
over 3.
Is that equal to 9?
No, that's not.
No, that's 4. So answer choice C is gone.
Okay.
And then I'll clear this. Answer choice B is gone. D is looking good. Let's confirm it.
All right. 0 equals 3 squared.
That's 3 over 2, right?
Yeah, that's what I'm. Yeah. Okay.
Is that a true statement? Is that a true statement, Jackson?
No.
What's anything times 0?
0.
Anything times 0 is 0. So 3 over 2 times 0?
So that would cancel out.
Yeah.
Oh, so it is a true statement.
It is a true statement. It is a true statement. 0 is equal to 0. So we can confirm it is indeed answer choice D. Oops. The nearest function. There we go. Does that make sense, Jackson?
Yes.
Okay. Don't forget that. Anything times 0 is 0. Remember that. Questions?
No.
Plug in values for the variables. Just do it. You will pass this test. All right, let's take a quick little 3-minute break. I have got to